So here I have a coin flip problem. So I'm flipping the coin 8 times and I'm keeping track of the number of heads. So I first want to check, is it binomial? I always want to ask that question first. And so I check, are there 2 outcomes for each trial? And the answer is yes, heads or tails. Then I have to check, is there a fixed number of trials? And the answer is yes. I'm flipping 8 times. Are coin flips independent? Yes. What I get on one doesn't affect the next. And is the probability of success, in this case heads, fixed? And the answer is yes. It's 0.5. So now that I know that it's binomial, I can go set up a probability distribution if I want. And on this particular problem, I would be looking at a particular probability. This time the probability that I flip exactly 5 heads. And so now what I know is that n is 8. That's my number of trials. And the one I'm interested in is 5. So it would be 8C5, because here's n, the number of trials, and r is the number of successes that I want. And then I have to do success. So I'm just gonna write this right now, which is heads, and I would like 5 heads, and then the fail is tails. I'm using the notation just so I'll remember later what I'm supposed to put in there. Well, if I have 5 heads, then that means I have to have 3 tails, because remember I was flipping 8 times. And so then I'm going to get my calculator and figure out what 8C5 is. If you forgot where NCR is, it's under math. Oh, remember you have to type the 8 first, and then go to math, probability, and it's number 3. And so 8C5 is 56, so I'll write that down. And then I want to substitute in the probabilities. So the probability for heads is 0.5, and the probability of tails is 0.5. And then I'm just going to plug and chug all of this directly into the hamsters to get 0.21875 on the next one. So this time I want to find the probability that I flip at least 4 heads. So at least 4 means I could do 4 or 5 or 6 all the way up to 8. So it's going to be greater than or equal to 4. So now if I do this by hand, I've got to look at 8C4 and then 8C5 and 8C6 and 8C7 and 8C8. And then of course the notation would be the same. I'd have heads and tails. On this first term I would want 4 heads, which means there'd be 4 tails. And on this next one I'd want 5 heads, which means there'd be 3 tails. And on this next one I want 6 heads, which means there'd be 2 tails. And on this next one I want 7 heads, which means there'd be 1 tail. And on this last one I'd want 8 heads, which means there'd be 0 tails. And then I'd go back and do the calculations for each one of those and add them all up. So I'm going to use the hamsters. Now remember, since I'm accumulating, I want to use binomial CDF, but CDF is going to add from 0 up through whatever, and I don't want it to do that. I'm not even including 0. So I'm going to want to write this so that I know all of them total 1 if I were to make a distribution table, and the ones I don't want are 0, 1, 2, and 3. So I'm going to type in this. So I'm considering the 1 minus less than or equal to 3. So now binomial CDF as well as PDF, it takes 3 parameters after it. And I forgot to do this back earlier in your notes, but it takes n, p, and x. And x is your number of successes. So our n was 8. Our probability of success, that was heads, was 0.5. And x is 3. And I want to do 1 minus this. So I'm doing a big fat 1 minus. So type that all in and pause this video and see if you can get it. So hopefully rounding to 4 decimal places, that's the value that you got. So this one is going to take us a little bit of time, but we're going to use the hamsters to help us. So I'm just randomly guessing on a 15-question multiple choice test where I have 4 choices, and I'm keeping track of how many questions I get correct. So of course I could get anywhere from 0 to all 15 correct. So now I would actually like to have the hamsters do each one of these, because remember, if I'm doing each one individually, I have to use combination notation. So this is what it would look like for 0, and then I'm going to say correct and incorrect. So C equals correct and I equals incorrect. And so on this first one, I'd have 0 correct and 15 incorrect. And then I'd go back and I'd put in the probabilities for each one of those. And of course, the probability that I get it correct, if I guess, is 1/4, because there were 4 choices. And the probability that I get it incorrect is 0.75. And so I would do each one of these individually. But that's going to take a long time to do all of those by hand. So I'm going to think smarter than a hamster. And I'm going to put this into the list. So I'm going to go to my stat editor and I'm going to use sequence. And I showed you this once before and I said you'll keep forgetting. So remember, the first one is the formula. So we just want a single number. And then the second one is the variable that we're substituting in for in that formula. Since there was only x, I'm only substituting in for x. And then where I'm beginning, so I'm starting at 0, and where I'm ending, and what I'm counting by. So you're going to put this at the top of list 1. So pause and get that done. So that's at the top of list 1. So now we're going to utilize list 2 to generate all the probabilities. And keep in mind that every single time I write this, what's changing will be this number here, and I'm getting that from list 1. And the exponent here will match, and then this one will be 15 minus whatever L1 is. So when I put it in, it's going to look like, at the top of list 2, it's going to look like this. It's going to say 15 C L1, and then we want 0.25, because that's the probability of success, to the L1, and then 0.75 to the 15 minus L1. So pause the video and get that in. If you're having issues getting the right answer and it's giving you an error, one thing that you'll have to do is put this all in parentheses. You might have to put this in parentheses. I did, because it kept giving me errors, so I made sure I put things in parentheses to help it be a little more explanatory for the hamsters. So here are the numbers that I got. So check to make sure that your numbers are matching mine. I'll assume if the first 6 and the last one match, that the ones in between match. And of course, remember, I can double check and sum list 2 to make sure that it does in fact add up to 1. Probably a good idea. All right, so now moving on to question or letter B, I want to find the probability that I get at least 8 correct. So of course I could add them up myself, but that would take a little bit of time. At least 8, remember, means I could have 8 or 9 or 10 or 11 or all the way to 15. So that would be greater than or equal to 8. So I want these ones here. And remember, when I use Binomial Pdf, which is cumulative, that it's going to add up from 0 to the beginning, so I don't want that. I want the later stuff, so I'll do 1 minus, and I'll do everything less than or equal to 7. Keep in mind, I could also write this as less than 8. Those mean the same thing because it is discrete. And so now I can type it in as 1 minus binomial CDF. And remember, the parameters are n. Well, n was 15. Probability of success was 0.25. That was guessing correctly. And if I want to get rid of 7, the first 7, then I have to put in a 7. So put that into your calculator and see if you get the same answer that I have. Did you get it right? Did you get it right? Let's move to the next one. I want to find the probability that I get exactly 10 correct. So now this would be just 10. Now I can look in the table and see what it is. If I'm looking in my table on my calculator that I just created, I have 6.8 times 10 to the negative 4. Of course, I could write that in scientific notation. It would look like 0.00068. And if I didn't want to look in the table, or I hadn't created the table, of course, I could do Binomial Pdf, since it's just 1. And again, it takes the same parameters, n, which is 15, p, which is 0.25, probability of success, and I want just 10. So now pause, put that in, and see if you get the exact same answer. Basically, I got exactly the same thing. Yay!